Assign charges and write a resonance structure. Well, let's take a look at this one. And so what we want to pay attention to here is hydrogen makes one bond, and each of the hydrogens in the structure is making one bond, so no charges on any of the hydrogens. Carbon makes 4 bonds, and each of the carbons in the structure is making 4 bonds, no charge on the carbon. Neutral oxygen makes 2 bonds, and this oxygen's making 2 bonds, and this oxygen is making 2 bonds, so there's no formal charge on either of the oxygens. Note that, you can count electrons too. Neutral nitrogen makes 3 bonds, and this nitrogen has 4, so that's the first thing that we might find suspicious in terms of trying to assign charges. If you want to count, this nitrogen has half of this bond, half of this bond, and half of each of these bonds, so that's 4 electrons assigned to this nitrogen. Nitrogen normally has 5, so it's short 1 electron, so our charge assignment is plus for that nitrogen, plus 1 if you want to be specific about the number, but plus tells us plus 1. Okay, how about writing a resonance structure? Well, there are actually 2 good resonance structures that we can write for this species where all atoms have an octet. So the first one, I might take this oxygen and make a bond here and kick a pair of electrons onto the nitrogen. What does that give me? That gives me a double bond here to this oxygen, and it still has the CH3 on it, and a single bond to this nitrogen, and it has a lone pair now, and this oxygen must have a plus to balance charge. So that's one resonance structure. There's another resonance structure, and I could use a lone pair on this oxygen, or if we start from this resonance structure, let's put that lone pair in, and there's 2 lone pairs. And we can generate the other resonance structure by pushing electrons this way. So that gives me this picture. Double bond now. Don't forget the formal charge on the oxygen. NH2. And no charge here. So these are the resonance structures for this species.